Jaideep, leave it. I have started OBS. Then I have
Okay.
started OBS. Yeah, you just leave that. Is the slide visible now?
No,
No,
sir.
sir.
No, sir.
No, sir, not yet, sir.
Uh, Maybe what is happening? I mean, can't share your screen. Dismiss. Oh, recording has started. Your screen. Let's see. Now, is it visible?
Yes, sir, it's
Yes, sir.
visible.
Okay. So let's start. Uh, so in the last class we had started discussion about arrays, and we have seen how we can represent a collection of data items of similar types and using a single name. And main 2 points I have highlighted in the last class is that each of the member of that collection can be referred separately, similar to similar as independent variables. Like they can be accessed for reading and writing, whatever may be purpose. And the other thing I have pointed out is the random access. That means although it is a sequential collection, we can directly refer any one of the items out of the sequence, and that can be accessed by the compiler very easily. That is the main strength. Now, in order to understand how this random accessness is provided, let us look into the memory organization of this collection a little bit. How this uh, collection of data items are actually stored in the main memory or RAM of the computer. Okay, and along with that, we'll also get some idea about how normal variables are also stored in the memory and how they internally gets managed. Okay, when we write the program without uh, anything specifically indicating where they are stored and how they will be accessed. So it is the job of the compiler who takes help of the operating system to carry out the entire process. That means when we declare a variable, compilers along with the help of the operating system reserves a space in the computer memory. And when we instruct through our programming several read write operation like getting the value of that variable or updating the value of that variable, everything is done by the compiler with the help of the operating system from that particular location where it has been stored. We don't have any control where to store. It is totally done by the operating system. But compiler has an access to that location. And based on our request, which we put as set of instruction in our programming, compiler does that. We don't have any control, but we can know that we'll see that we can know where it has been stored. Okay, we cannot update the storage location, but we can use that location to manipulate the data. Okay, so without understanding lots of complex thing right now, let us just think of a logical representation of the memory. Like in main memory or RAM, you can think of it is organized as a table, like table or matrix, whatever you call. It has some rows, it has some columns. So typically, logical organization may be thought of as a table like this, where there are 8 columns. 8 columns means this row, each row has 8 spaces. Okay, which we call bits. So each of these small box can contain either a 0 or 1. Okay, so there are 8 bits that can be stored in a row, 8 bits or 1 byte. Okay, and the number of rows will depend on your memory size, that how much memory you are having. Typically, the number of rows is represented as 2 powers of some m. Okay, like when you say my RAM is 1 GB, so it will be like 2 to the power 30 such rows of 1 byte. Okay, so now each of the rows are also identified by numbering or indexing. Okay, the first row you can consider, it is identified by the number 0. Then the second row 1, third row 2 in decimal in this way. So last row in the memory is identified as a number which is 2 to the power m minus 1. Okay, so these are the decimal numbering. Now actually everything in computer is represented as a binary. So it will be converted in the suitable binary form, like it will be all 0000, then 0001, like that. But for our uh, easy reference, we will actually represent, I mean think of that this is numbered as decimal. Okay, like you may think of this we call that memory address. Each of these identification number of this row is called address of the memory. So this address is used to uniquely identify these rows of the memory. Understood? So this 1000, basically this is 1000 in decimal. It is we call address of this particular row. That means it is the 1000 number row starting from the 0, actually 1001 number row. Understood? So when we typically declare a variable, let's say int a, in our program. Now when compiler gets this particular instruction, what compiler does, it requests operating system to reserve a suitable space in the memory such that an integer variable can be stored. Okay, now what operating system does, it knows that size of the integer is 4 bytes or 32 bits. So it's suppose it chooses this location 1012. Now it reserves 4 rows because each of the row can store 1 byte. So 4 contiguous row, 1, 2, 3, 4. This 1012 to 1015, this entire space is reserved. And initially when we don't put anything, it contains garbage value. That means all these, there are 32 cells in together, 8 into 4. Each of them contains some 0, 1 pattern. We don't know what is stored. Am I audible, student? Are you getting my point?
Yes, sir. Yes, sir.
Okay. Yes, sir.
Yes, sir.
So this is done. Now when we say write this statement a equal to 5, that means I am putting a known value inside it. Now what does compiler do? Now once operating system has assigned this particular space, compiler has kept a match that okay, a variable a is stored in a location starting from 1012. So now it can easily go there. We as a programmer know the variable name only, but to compiler this mapping is there. Once we have compiled and run the program, compiler has the matching that a means its address is 1012. That means a has been allocated space starting from 1012, and how many rows are there? Since it knows that integer is stored with 4 bytes, so 1012, 1013, 1014, 1015, these 4 bytes have been reserved for this. So it automatically goes there 1012 location, and it stores this value 5. Now how this value 5 is stored? The 5 is in decimal. Now it will be converted into binary 101. Now it is only 3 bit. Now it has 32 bit location. So it will be extended by padding zeros Like there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 29 zeros. 29 zeros, then 30th place will be, oh no, 28 zeros. Oh no, 29, sorry, 29, then 30th space will be 1, then 31 space will be 0, 32 space will be 1. So this will be extended into 32-bit, and it will be stored like all 0 in this first row, then all 0 in the second row also, all 80, and all 80 in the third row, and there will be 5 zeros in the fourth row, and then 101. In this way it will be stored. When we update this value, the same thing will occur internally. The decimal value will be converted into a 32-bit integer, binary integer, and that will be updated here. This is the process. Similarly, for a character variable, only one byte will be reserved. So depending on the size, the number of contiguous bytes that will be reserved may change. But every case, the first byte, address of the first byte or identifier number of the first byte will be acting as the reference to that value. And this is called address of the variable. And sometimes we can actually put that value. We don't have any control. That I cannot say as a programmer that okay, you store this A into 1024 location. I don't have that access. But once operating system has reserved a space, I can get that value where it has been stored, and I can take that value inside another variable, special type of variable in C that we call pointer variable, which uh, will be discussed in a little bit more detail by Joydeep sir in later point of time. Okay, and we can use that value. Remember, we cannot update, we cannot change this position, but we can use that value for some typical work which we'll see later. Okay, understood. So this is the way internally variables are represented inside memory. Now, how it is related with an array? Let's see. Now, when we declare an array like this, suppose for simplicity we are declaring an array of only size 5. So what compiler does? Now it knows that it is not a single integer variable. It has to store 5 integer variable contiguously. So it reserves a space which is starting from some location, can contain 5 integers. So it will reserve a space of 5 into 4, 20 contiguous bytes. Understood? So first 4 byte will be reserved for 0th element of the array. Next 4 byte, the first indexed element for that array, like this. Okay. Now, only this address is sufficient. This value is sufficient to know everything. Because this is contiguous, you know the number of bytes taken by each of these member, because that is dependent on the variable type, data type, and how long you will go, that is dependent on the size. Understood? So this particular starting address is formally known as base address of the array. So we as a programmer refer our array with this name X, but internally compiler refers this array with this base address. Let's say for this example 1000. Using this base address, whatever operation we ask compiler to perform, it can perform, because it is already given by this data type that okay, you have to store 4 into 5, 20 contiguous byte, and after each 4 bytes there will be a new member. So base address means 1000 will be the address of the first element or 0th element. Now from this 1000 it can also easily compute the address of the second member just by adding 4 with that, because it knows each integer takes 4 bytes. So next member will start from 1004. Similarly the next will be starting from 1008, like that. So you can generalize this formula. The element with index I is located at the address B plus C into I. Are you got my point? If you know, since compiler knows this base address, also knows the data type, so this C is known. C depends on the data type. For integer it will be 4, for character it will be 1, like that it will change, and I will be the index. So by computing this expression, it can directly, it don't need to calculate that 1000, then 1004, then 1008, not like that. You, when you ask it to update x3 by say some value minus 4, so how does compiler reaches x3? It will just use this formula. Since it knows that x starts from 1000, so it will compute 1000 plus C is 4 byte, since the data type is integer, into I is 3. So it will be 1012. You see, what is the starting address of x3? 1012. So this is the whole key process that allows compiler to randomly access any location in the array without going sequentially. Just this is the easy formula. It will internally compute and it can reach any particular member element of the array just by one exercise. And that's
Sir,
how
I have
this
a
random
doubt
accessness
why.
is provided. Understood?
Sir, I have a doubt why you multiply by 3.
Huh?
Why you multiply 4 by 3?
This is I, the value of I.
Where you find I can't I got not get it.
See, your base address starts from 1000
Yes,
or B. Now, for each element, you have to jump 4 bytes for the integer or C bytes in general.
yes, sir.
Now,
Yes, sir.
how many 4 bytes or how many C bytes you will jump? That will depend on this index I.
Mm, yes, sir. Yes.
Understood? So
Yes, sir. Yes, sir. Yes.
x0, what will be the address of x0? X0 will be the address of the base address, exactly base
Base
address
address.
0 into 4. Then x1, 1000 plus 4 into 1.
4 into 1.
Yes,
4.
for 2, it will be 1000
1000.
plus 4 into
4
2,
into 2. Yes, sir. I
like
got it.
that. Understood? So actually, as a programmer, you just need to know that thing. You don't have to do this calculation. I am saying how internally this thing is managed. Okay. So let us take some more example. As I have already said, this one, the same example you see. So compiler internal computes the address of x2 as follows. Base address plus this is C in this case and this is I. This is general formula. It holds true for any array and for any data type. But for this example, B is 1000 and C is 4 since it is an integer data type, and I is 2 because I have given this index. That's all. Understood? So logically what we'll see? We'll see that after this statement gets executed, instead of having all garbage values, the two index, this member will get a known value 13. But how does that is done? internally. Internally, compiler computes this and reaches this particular address and updates that value. And this is the decimal value I am showing, but as I mentioned, internally it will be, this 13 will be converted into a 32 byte signed integer, which will be stored in 32 bits, possibly padding several zeros. Okay. Following the thing Joydeep sir has already mentioned, how to convert signed integer, decimal integer into binary, the 2's complement form. Okay. Fine. Now, when you read, same thing happened. When you read, try to get the value from the user during runtime. We used to write this statement. Now again, compiler has to reach this particular location. So it will again compute that. And if so far you have not understood why you have to use this ampersand when scanf. Inside the scanf function, you have to use ampersand operator before the variable name, either in the normal variable or this array element. This operator, you have already seen the use of this ampersand operator in other cases, like this double ampersand used as logical AND operation. Single ampersand you have seen bitwise, bitwise AND operation. Now, when it actually, the meaning of this same symbol varies depending on the context of use. Like when it appears before a variable inside this type of scanf statement or somewhere else, which you will see later, is this now called as address of operator. This is called address of. Okay, I am coming to that. But anyway, so it has to reach the address of x3. Now again with the same formula, it computes that location and updates. Suppose user enters minus 5. So minus 5 will be written here, not anywhere else. Okay. Now this address of operator is very useful. Like when this is there, internal calculation is done like this. So address of the entire array is basically, this is very important thing to remember. Address of the entire array and address of the first element or 0th element is same. That you should remember. Understood? The base address. Now, the next
Yes,
element,
sir.
address of the element at index 1, how it is computed? It is as if ampersand x plus 1, whole x plus 1. Now, value of ampersand x is basically 1000, and this ampersand 1, this is computed just by setting the offset of 4 bytes or C and multiplying it by I. In this case, I is 1. So in this way, the different addresses are computed. Okay, you will see this thing, this operation, application of this operation more in as pointers. Okay, when Jaideep sir will discuss pointer variable after your mid-sem is over, then you may understand this thing, a use of this particular operator more. But you have already seen that in scanf you have to write that. Now you can understand what is the meaning of that. It is just to indicate that it is indicating address of that particular variable where it has to reach and update the value given by the user. Okay. Now there is an interesting thing you should know. You may not use it, but you should know. Like this thing, this statement is correct. We used to write this thing in program. So as we have seen already, this x2 will be, address of x2 will be computed like this, x2 equal to ampersand as if x plus 2, following this strategy. So amperes and x is plus this 2 into 4. Now amperes and x in this particular case is 1000 plus 8, so 1008. This will be computed, and accordingly starting from that location this minus 3 will be written. Now you will be astonished that if you write like instead of x3 equal to minus 7, which is correct, if you write this one, this will not generate any error. This is also a right state. We will never recommend that you should use write like this in your program, but it is just to let you know that if it is written somehow by someone, it will not generate any error, or it will do the same thing. This statement will act equivalent as this statement, just because this thing is done internally like this. So 3 plus x is equivalent to x plus 3, and with that logic it acts equivalent. It will not generate any error. So you can write a program and check that it may work properly. So this is the reason. So whatever you write amperes and 3 within square bracket x, which is not recommended, but even if you write, it will actually act like as if you have written x within square bracket 3. Okay, this is just an aberration, you can say, which is there in C. So you should not get confused that it will not work. Why it is working? But it is working because the internal computation is done like this. And 3 plus x and x plus 3, or whatever. I mean, it is not only 3. For any index within the range of this array, it will work. Got it?
Yes, sir.
Okay. So with this sort of uh, introduction to memory organization, let us try to move on some example program, small example where we'll be using array. We have seen one motivational example in the last class. Now we will be dealing with few very common and popular sorts of small problems where the use of array is very evident. Okay, before that, we should know that how for loops are used with arrays. As we have already seen some example, like how using for loop we can initialize the elements of the array. Hmm. But when we are dealing with array, we will be using for loop much. Okay, for example, like this. This is the initialization. The, I mean, hard coded initialization, like we are initializing in the body of the program. Now if you want to initialize or get the values of the elements from outside, from the user, you have to use for loop with a scanf statement like that. Okay. Similarly, if you want to update all the elements with some common type of operations, okay, then also you can do that within the for loops. Okay. Now, as you have seen, we cannot print the entire array with a single statement. We have to, that is illegal. We can only print the elements one by one, or just by using a for loop like this. Understood? So we will see. I mean, we'll see that the use of for loop will be quite uh, you can say intuitive in many program when you deal with arrays. Okay, so these are few examples. Now let us take this simple example program. Write a C program that takes 5 numbers as input from the user and outputs the largest number. Again, I actually the program will be uh, has to be written for very large number, but for illustration I am taking only 5 numbers, otherwise it will be very difficult for me to illustrate. But later on, as an exercise, you should take this value larger, like say 100 or 1000, whatever. The same procedure will be applied. Let's take with the 5x number to understand the proceedings. Okay. So first of all, what we have to do? We have to declare an array of size which is at least as large as the number of elements I am going to consider. So in this typical example, I need only 5 numbers, so I am declared an array of size 5. Now if you ask me that you have to write a program that takes some 100 elements, then I will declare a size 100. Okay. Or you can generalize the program that, okay, write a program that takes any number, any n number of inputs. Then as I have mentioned, since this static array does not allow me to declare the size with the variable size, so I have to consider that, okay, how long my how large the value of n can be at any point of time. So within that program I have to restrict that, okay, uh, I can accept any n, but that should be less than 1000. Okay, so that I can declare the size of the array to be 1000 without any problem. Okay, although I am saying it is n, but I cannot write a program using this static array for any value. Any value, there must be some restriction. I can take some large value. Okay, so I'm coming to that later. But first of all, let us see that we are writing the program for some fixed number, either 5 or 50 or 100 or 1000 or 1 million, whatever, but that is fixed. Then what we are doing? We are doing like this. We are declaring, okay, and we are also declaring some variable like this I am using, declaring as if uh, as it is quite evident that I will be using a for loop to get the values and do some other operation. So I will be using that for loop as a loop control variable I, and the max I have declared so that I can take that the largest number which I will compute and print at the end will be collected inside this max variable. So in this way I declare the required variable. Maybe I may need some more variable which I will add up later if it is needed at all. So once I do that, what is the meaning? Inside the memory, logically, I am getting a collection of, I mean getting one space where collection of 5 element can be stored just like array, and all the elements values are unknown or garbage. Similarly, there will be in memory, there will be one 4-byte space which can store an integer and named as I, and similarly there will be another integer space, and initially all of their values are unknown or garbage since I have not assigned anything. Okay, next I am going to read the input numbers from the user. So this is typical for loop I have shown in the earlier slide, that since my size is fixed, I will go for I equal to 0, I less than 5, I plus plus, scanf, ampere short. So on each iteration, this for loop will run for 5 times for values I equal to 0, then I equal to 1, I equal to 2, I equal to 3, and I equal to 4. And each step it will collect the elements one by one, starting from the 0. Okay, let us say like this. Iteration 1, if user inputs 3, then 3 will be written logically in the first place, and i's value was 0. Okay, now it will be updated. Just going for the next iteration, before going for the next iteration, the update steps will execute and value of I will automatically be increased to 1. Okay, and the next value will be put inside. Huh? So I am assuming these values are given by the user at any particular run. So in this way, it will be populated. And when value of I becomes 4, the next time when it is going and it gets increased to 5, then this condition will become invalid. So after iteration 5 with values 0, 1, 2, 3, and 4, it will stop, it will complete, iterations complete, and that time value of I remains as 5, and already the array has got populated with the value that has been input by the user. Max is still uninitialized, okay, with garbage value. Now next, once I have got that value, now I have to do the actual thing. I have to find out the largest number. Now how do I find out the largest number? If you remember, I had while discussing the last portion of the decision making based branching, I had illustrated how you can find out the largest among three numbers. I had shown you three techniques, and also judge which one was the efficient and which one was the less efficient. And I had indicated that one solution which takes a little bit more computer number of computations, like two comparison plus one assignment, as opposed to only two comparison for the most efficient solution we have found there. And I had mentioned that time that that strategy may be used for larger number of inputs. When we have to find out the largest among more than three numbers, then that particular strategy will be useful. And I am, if you can recall, then you can relate the strategy I am employing here. What I am doing, I am initializing max variable with x0. Okay, the first element. I am assuming that, let us take this as max. Obviously, it is not yet guaranteed whether x0 will be the maximum, but I am initializing max. Okay, so this statement. Next, what I am doing, I am now comparing the content of the max with each of these other elements of the array. I'll go next and check whether the content of this element is larger than my current max. If it is so, then I will just update with that value. Update the content of max with that value. Otherwise, I will leave it. I will do not update it. I will go for the next element. And I'll check again with compare the content of this and compare the content of the current max. So same type of thing I'll be doing for all the remaining elements of the array. On the one hand, I have my max having some value in it, and on the other side or other hand, I am having one element of the array currently I am inspecting. Now I will compare. If on the right hand side I have got a new value which is larger than my left hand side or the current max, then I will update my current max with that right hand value. Otherwise, I will do nothing. I will just leave that and go for the next element. So if I do that thing and I can inspect each and every element, at the end, whatever content that will be inside max will be definitely the largest element. Are you getting my solution recipe or algorithm?
Yes, sir.
Okay, so that strategy can be easily written using this for loop. Now, inside the for loop, what I am doing? Already I have initialized with 0th element. So I am leaving. I am not starting with I equal to 0. I am now starting with I equal to 1. That means this. And I am repeating the same set of procedure. If this condition gets satisfied, then I will update. Otherwise, I go for the next iteration. Understood? So let us for beginners, let me illustrate the iterations one by one, just like I had illustrated the iterations one by one here. So first, value of I equal to 1. Okay, and remember this block of statements will be running for 4, not 5 times, because it starts from 1, and we don't need 5 times because x0 has already been taken care of. By default, we are assuming that it is the initial max, so we don't need to compare it with that. We have to consider only remaining 4 elements. That's why it starts from 1 and ends at 4, less than 5. Okay, so first time value of I was 5, but when it enters in this for loop, I will be initialized with 1 again. Okay, so I equal to 1. In my max I have 3 and xi I have minus 2. Obviously this condition
Hello.
becomes false. Yes, anything? Any doubt?
There was a disconnection of uh, your line. So you may please repeat from the third line. Okay.
Okay, so what I am telling, when I'm going inside this particular loop, the value of I gets initialized to 1. Here I had left the value of I as 5, but when I move into this particular iteration or for loop, then value of I again gets initialized with 1. Same variable I can use because this job of this I is done. Okay, now this is same variable I am using with properly initializing that. Now the first iteration, what it will check? What is the value of I? 1. So it will check whether x1, that means the content of x1 is minus 2, is greater than max. Max is holding the value of x0, which is 3. So this will be checked. Since this is false, this statement will not get executed at all. It will be skipped because it is within the if statement. Okay, so it will be left. Remaining max, the content of max remains unchanged after first iteration. Now in the second iteration, value of I becomes 2. So now the comparison will be done between x2 and the current content of max. So 7 and 3. Obviously now this becomes true. So what will happen? These statements will get executed. So max equal to x2 will execute. That means the content of max will now get a new value, will be updated to 7 from 3. Okay, like this. Got it? Now automatically value of I will become 3 now. So we will move on to the third iteration. Again same type of operation. Now we are comparing with x3 and current max. x3 is holding value 9 and current max is holding value 7. Okay, so again this condition becomes true. Again this statement gets executed. So the content of this max gets updated to 9 from 7. Like this. Okay, so at the end of the iteration 3, value of I gets updated to 4. Again this condition is still satisfied. So now the comparison will be done between x4 and the current content of max. Now this time this condition becomes false. So this particular statement will not get executed and iteration 4 will complete. Fine. Now at the end of iteration 4, value of I becomes 5. Now when it goes for next iteration, this condition gets dissatisfied and in this way the loop terminates. And we see, since we have inspected all the elements and whenever we have got a value larger than the current max, we have updated. That's why at the end of this iteration, the content of max is basically is the largest element among all these 5. Okay, so finally we need to just print that content of the max. Our program is done. So we'll write printf the largest number is max. So this is the way, this is the program, and we can easily see how internally this thing is done and how we achieve to the correct solution. Have you got this?
Yes, sir. Yes, sir.
Okay, so now you can easily extend this program, same program. You can write You can update actually, as I have mentioned that for easy illustration, I have taken the value n to be 5. Now you can generalize with some restriction. This value is not important. You can make it 1000, 1,000,000 or whatever may be your choice. Now the structure of the program will remain exactly same. This program, instead of just making it 5, this size, you can use a symbolic constant as I have shown in the last class. Size to be 100, 1000, whatever. You can before main you can declare has defined size 100, and instead of 5 you can use here size. You can use your size. Now if you need
Sir,
this,
the alphabet of the size is the capital, sir. Define
whatever, I
size.
mean obviously it is good to use capital letter, but whatever you write here you have to write here also.
Okay, sir.
Okay, because these are case sensitive. So it is always a conventionally you should use capital letter for symbolic constant. That is usually we used to do that. Okay, so instead of using small letter you can use capital letter like this everywhere. But my intention is that by doing that you can write the program for 100 numbers. You can change it to just changing in one statement. You don't need to change everywhere. That is the main advantage of using a symbolic constant. Understood? So you can try. We will see in the uh, next lab class. I will not update this particular example. Okay. I will not upload this example. I will upload this after uh, Wednesday lab class is over. Okay. You can
Sir, we
for
have to
beginners. I
put
will.
some value to n.
Hmm? Hmm?
Sir, we have to put some value of
You,
n,
you
then
you
we have to
should
solve.
write a scanf statement
Oh,
through which
yes,
this
yes,
value of n for different run user can enter different value. Understood? But
yes,
he or she can never enter a value which is larger than 100. That is the point.
okay, sir,
So
okay, sir,
that
I got
by
it.
declaring an array size 100, program can run with different values at different run, same program. Okay, this
Yes,
value
sir.
of n will be taken as an input, but it should not be considered as the size of the array. Size of the array is fixed to 100. So you can when you are asking for the input, you can write a printed statement like this: enter the number of inputs which must be less than 100. Then you can issue the scanf statement. Understood?
Yes, sir, I got it.
But remember, you should not use this value of n to be size. Size is already fixed to 100. So that you can tackle any value less than equal to 100. Actually, you can here less than equal to also you can write. No matter. Got it? So I am stopping here today. In the next class, we will see some more example, more popular example of I mean this type of problem which can be solved using array and for loops. Okay. So if you have any doubts, you can ask.
স্যার
হুম,
বলছি অ্যারেতে যে
হ্যাঁ
স্যার
বলো।
অ্যারের যে
হুম
অ্যাড্রেসটা
হুম
স্যার এটা আমরা চেঞ্জ করতে পারবো না
না,
স্যার
অ্যারে কেন কোনো ভ্যারিয়েবলেরই অ্যাড্রেস তুমি চেঞ্জ করতে পারবে না, বাট ইউ ক্যান অ্যাক্সেস, you can know that where it is stored, what is the value of that address. Okay,
আচ্ছা স্যার বলছি একটা আলাদা কোশ্চেন তাহলে পিটিআর প্লাস প্লাস দিয়ে কি হয়?
হ্যাঁ,
আচ্ছা পিটিআর প্লাস প্লাস দিয়ে কি হয় তাহলে?
that will be discussed by Joydeep sir. That's why I'm telling you can take that value. Okay, you can take that value inside a variable. Fine. So base address you have collected inside a variable. Now when you increase that increment by plus plus, that means you are getting the next address. So
Okay, sir.
if you just collect the base address in PTR as you are telling, let's say that
Yes,
was
sir.
1000. Okay, now when you issue a instruction like PTR plus plus, that means 1000 gets incremented by 4. You will get 1004. Now you can use that value to directly access the second location. Instead of issuing x1 equal to 3, you can use that value of PTR to do your job.
Okay, sir.
Understood? That is the difference only.
Yes, sir. Understood.
But you cannot change that. You cannot ask operating system or compiler, okay, you shift the array from 1000. It is as if it was starting from 1000. Okay, now I want PTR plus plus, it should start from 1004. You cannot do that. Okay.
Okay, sir.
Okay.
Okay, sir.
Okay, Joydeep, you may stop the recording.
Yes. Okay.
Now, and I also. So if you don't have any further question, we can conclude today's class.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.